going to explain the implementation of the Navy Bayesian classifier. First, what is Navy Bayesian classifier? It is a supervised machine learning algorithm used for classification problems. It is based on Bayes' theorem and assumes that all futures are independent of each other. Navy Bayes work based on Bayes' theorem, which is P of A given B equal to P of B given A into P of A divided by P of B, where P of A given B is a posterior probability and P of B given A is a likelihood. P of A is a prior probability and P of B is a evidence. The class with the highest probability is chosen as the predicted output. And algorithm. First, load data set. Step 2, label the data. Step 3, split it into train and test data. Step 4, fit the data. And finally, calculate the accuracy and print it. This is the data set for our program. Next, first we import the record libraries. We import pandas to load and handle the dataset. We import train test split to divide the dataset into training and testing data. We import Gaussian NP, which is the Navy Bayes classifier. We import label encoder to convert categorical values into numeric form. And finally, we import accuracy score to measure the performance of the model. Next, we define a function called loadData. This function takes the file path as input and reads the CSV file using pandas.readCSV. It returns the dataset as the data frame. After loading the dataset, we pre-process the data. Since machine learning models cannot work with the text values like sunny, rainy, or hot, we must convert them into numbers. For that, we use label encoder. We apply label encoding to all future columns and also to the target column. This converts categorical values into numeric form. For example, sunny may become 0, overcast may become 1, rain may become 2. After encoding, the function returns the updated dataset. Next, we define a function to train the Navy Bayes classifier. Here, we create an object of Gaussian NP. Then we call the fit method to train the model using training data. This step builds the prediction model based on probability. Then we define a function to compute accuracy. Inside this function, we use predict to predict the output for test data. Then we compare the predicted output with the actual output using accuracy score. This gives us the accuracy of the model. Now, in the main execution part, we load the dataset, then we print the first 5 rows of the original data to see how it looks before encoding. Next, we pre-process the dataset to convert categorical values into numeric form. Then we separate the futures and the target variable. X contains all input futures, Y contains output column, which is platelets. After that, we split the dataset into training and testing sets. We use 80% of data for training and 20% for testing. The random state ensures that we get the same split every time we run the program. Next, we train the model using training data. Finally, we calculate and print the accuracy.
Thank you for watching.